These are notes 20. You should have this set up already from class. We're going to solve by elimination and substitution today. The essential question, how do I solve a system of linear and quadratic equations? The warm-up should be done. It's a review on factoring because you need to know how to factor to solve the quadratics. This is the second day of 12-10 notes. It's from page 803 in the book. All right, so go ahead and copy this down and we'll get started with our examples. Pause if you need to if I'm going too fast. It says, in the past, you solved systems of linear equations using elimination. And you can use the same technique here. So here's our example. We're going to solve these two equations. You should be able to look at them and tell which one's linear and which one's quadratic. The linear has x to the first. The quadratic has an x squared. Linear would be a line if you graph it. Quadratic would be a parabola if you graphed it. We're not graphing today though, but you could solve these by graphing. That's what we did on the last notes. So here are the steps, and I'm going to go ahead and do one step at a time. So the first step is we need to cancel out the y. You might have to multiply by -1 to the whole equation so that the y's would cancel out. So in general, when you solve by elimination, you want to cancel one variable, so either the y or the x. But in this case, with the x squared and the other x term, you really can't cancel out the x. So that's why I put in the steps that you're going to be canceling out the y. So let me show you how to distribute by the -1 so that you can cancel out the y's. So it doesn't really matter which equation you distribute through with a negative. I guess I could just do it to the bottom equation. It really doesn't matter though. So I'm going to distribute -1 to the whole equation. And I think I'm just going to write it to the right. It should fit. So I'm going to leave the top equation the same. All right, I'll just use purple. So I'm going to leave it y equals 36x plus 54. That's my linear equation. I'm not changing anything. On the second equation, I'm distributing. So the negative goes to every single term. It just switches the signs. So it's going to be negative y equals, so now it's negative x squared. So negative times a negative makes it positive. So x squared, I'm going to try to line up the like terms. This one will now be minus 39x. And then this one will be minus 64. And basically it's like an addition or a subtraction problem. But the point is we need the y's to cancel out. So that's step one, cancel out the y's. They cancel and it's left with a 0 equals x squared is still there, but now I'm going to combine like terms. 36x with the negative 39x and 54 minus 64. So that's going to be negative 3x. And then that was positive and negative, so the bigger number's negative, so minus 10. So I'm left with that equation. I'm going to write it a little bit nicer right over here. So this is what I get. 0 equals x squared, x squared minus 3x minus 10. Okay, so that's step one. Now step two, solve the remaining quadratic. Remember, there's 5 ways to solve quadratics. The easiest way would be to factor. So I'm going to see if I can factor like that. It's going to go x, x, one sign's plus, one sign's minus, and then I just have to find the two numbers. Again, I know it's opposite signs because they multiply to give -10. My options are 1 times 10, 2 times 5. One of them has to be negative, so they subtract to give 3, so then it would be 2 and 5. I just have to be careful which one gets the negative it's a minus 3x. So notice even going back here, it's very, very important that you have the correct signs. If I messed up the sign here, then I would be factoring wrong, solving wrong, and everything else would be wrong. So be very careful. Anyways, since it's a -3, my bigger number has to have the minus. So the 5 goes with the minus and the 2 goes with the plus. If you remember how to solve, we use a zero product property. So I would now set both equal to 0, x plus 2 equals 0, x minus 5 equals 0. So remember, there was a reason we learned how to do this. Then you solve, so I get, I'm going to just write it a little to the side, I get x equals -2 and x equals 5. So that's great. I solved for x, but I'm not done. So just to review, we canceled out the y. We are left with the quadratic. It should always happen that way. Then the easiest way is to solve by factoring. If it does, this one did. Then I use a zero product property, and I get my 2 answers for x. If it didn't factor, you could use quadratic formula. You could complete the square. That's a lot of work. You could maybe solve by square rooting. Maybe there was no middle x term, and you could solve by square rooting. You could use Desmos real quick and graph and find where does the parabola cross the x-axis. Remember, that's your solution. So there's a lot of ways. Factoring is the easiest. I recommend to factor. Most of them should factor because they make these problems on purpose to like not be that difficult. So the problems on Desmos or on Math Excel for your homework, they should factor. All right, anyways, we're going to step 3. I'm going to highlight my answers. It's not the final answer, but we're going to use those. So it says substitute the x solutions, so there's 2 x solutions, into the linear equation to get y values. So if you remember from when you solved like in Math 1, you would have to do something very similar. You substitute back into the original equation. Oh, and then you can get, sorry, then you can get your other value. So we'll do one at a time. There we go. Okay, so I'm going to substitute my x values into the x for that equation. I could substitute into the quadratic, but then I'd have to substitute for the x squared and the x. It's a lot more work. We don't want to do more work. So to get my first one, I would do, well, let me copy the equation. Y equals 36x plus 54. So I'm going to substitute my x values in for the x. So one of them will be 36 times -2 plus 54. And then the other one would be y equals 36 times 5 plus 54. Okay, so just so you see that we're going to solve both of those, and then our final answer will be 2 ordered pairs like that, and x is 5. Then I have to get my y value. So see, the y value has to correspond with the correct x. All right, so anyways, feel free to use calculators. I'm going to use one so that I make sure I do everything right. We have 36 times -2, and then you add 54. All right, I'll write down the steps. That was -72 plus 54, and then we end up with y equals -18. So that is one point where they would intersect, the parabola and the line. And then the next one, I do 36 times 5, 180 plus 54, 234. And so those are my 2 solutions. So that's how you solve using the elimination method. Not too bad, but just remember that initial step where you will probably have to distribute by -1. You could have done that to either equation. I was noticing that x squared has a negative in front, so that kind of helps to make it positive. It is easier if you have a positive x squared. So anyways, you eliminate and then you solve the quadratic, you get your 2 x values, substitute them into the linear equation, not the quadratic, that would be more work. And you get your 2 ordered pairs, x comma y, and those are the points of intersection between the parabola and the line. All right, pause if you need to finish copying that. Otherwise, I am moving on to the next part. I'm just going to try to fit it in here, but I'm pretty sure I'm going to have to go to the next page. So go ahead and start writing this. I did fit the steps. I wrote them really short. Feel free to add more to it. I didn't add a lot of detail. I was trying to fit it on one page. So that was the elimination method. This one, it says in the past you have used substitution to solve a system of linear equations, and you can do it here too. Pause if you need to. So here's the example. We're going to solve this system of a quadratic and a linear equation. The steps are substitution. So we're going to substitute for y. In normal linear equations, when it's too linear, you could substitute for y or for x. But again, since it's quadratic, the x squared makes it kind of tricky. You would have, if you're going to substitute for x, you'd be putting y plus 80 in for x and then squaring it and putting it here. It's just going to be a mess. It's going to be so much more work. So I'm going to substitute for y. I'll show what that looks like. Then solve the quadratic. It should be very similar to the last one, and then we'll get both the x and y values. All right, so first I'm going to substitute for y. Whichever equation has y by itself, you can substitute into the other. So for example, if this one, if I wanted to, I could subtract 80 to that side, and I could substitute in x minus 80 right here. But since this one already has y by itself, I don't mind substituting this whole part. Since that is equal to y, it can go right there. So again, you should kind of remember doing this from Math 1. It's called the substitution method. I usually just circle that part and draw an arrow to show that that is substituting in. So we're kind of like combining both equations into one by substituting an equivalent expression for that variable y. So again, that's step one, substitute for y. So I'm going to write this one. I'm going to write everything the same right here, except instead of y, I'm going to write that part. So I'm going to write x and then equals. And then instead of y, I'm going to put negative x squared minus x plus 19. So that part goes in for y, but then I still have my plus 80 from the original equation. Okay, so that's what we end up getting. Notice how here there's no y's. We wouldn't be able to solve the quadratic like by factoring or anything like that if there was still a y. So that's one way you know that you're on the right track. All right, so we don't want a negative in front of the x squared. So what I can do is just add or subtract everything over to the other side. There's other ways to do it too, but I think that would be the easiest for right now. I also want to combine these like terms. So I'm just going to do that right here. 19 plus 80 would be 99. So instead of subtracting 19 and subtracting 80, I'm going to subtract 99. I just combined them. Okay, so let me show the work. I'm going to add x squared to both sides. I'm going to add x. Oops, that's a like term for that one. It's going to get kind of messy, sorry. I'm going to make sure I add them together. And then the last one is it's positive, so I have to make sure I subtract 99 to the other side. So I'm subtracting and adding to get all the terms on the left side. It's a little messy, sorry. Those cancel, those cancel. So I'm going to write it in descending order from the highest exponent, x squared. Then x plus x would be 2x. And then minus 99 equals, the whole point of this was to make it equal to 0. So that way nothing would be left on that side. Okay, I'm going to have to switch to the next page, but I'm going to next, my steps will be solve the quadratic, factor if possible, quadratic formula. If I could isolate the x squared, I would do it that way and solve by square rooting, but I can't. So anyways, I'll solve the quadratic and then I'll get both x and y values just like we did over here, where I have to substitute my x values into the linear equation. Okay, so I'm going to turn my page. Okay, so I just flipped my page, rewrote the problem. I'm going to see if I can solve for x by factoring. That's the easiest way. If not, I would go to another method. I'm thinking this might factor. So I have to think what times what is 99? 1 times 99. There's 9 times 10. 3 times 33. That's probably it. So which of those, and also I can see it's negative 99, so I have opposite signs, 1 plus 1 minus. My middle term is a positive 2, so my bigger number has to be plus, but they would subtract to give 2. 1 and 99 don't subtract for 2. Oops, that's 9 times 11. I saw right there, I made a mistake. Those do subtract to 2. 3 and 33, no. So I can tell it's going to be 9 and 11. The bigger number goes with the plus so that I have positive 2. So I factored it. And you want to make sure you do factor it correctly. I'm double checking everything and it is. Set each factor equal to 0 and solve for x. So x equals negative 11 and x equals positive 9. So those are my x values. And then the next step is I just have to get my y values. So I look back and get the linear equation. So it's really similar to this last step from elimination. I just didn't have room to write it. So get both x and y values. We will substitute the x solutions, we got 2 of them, into the linear equation to get y values. So looking over here, my linear equation is x equals y plus 80. So I'm going to use that, x equals y plus 80. If you wanted to, you could get y by itself by subtracting 80. So y would equal x minus 80. It doesn't matter. You could have done it that way, but since I'm solving for y, it's a little bit easier here. So I would do x or y equals, substitute negative 11 in for x, so negative 11 minus 80. And then for the other one, it would be y equals, substitute 9 in for x, 9 minus 80. And then you just solve. So here you're adding because they're both negative, so negative 99. And here it would be negative 71. So I get my 2 answers for y, and my last step is to just write my answers as an ordered pair. The solutions are, for when x is negative 11, y equals negative 99. And when x equals 9, y equals negative 71. Okay, so remember that from graphing, we saw that there can be 2 solutions, 1 solution or no solution. Just to remind you guys what that looks like for the graphs. I'm not really graphing it, but this one, it had a negative parabola, and then or like a negative in front of the x squared. And then this one, I think, has a positive slope. So maybe it goes through kind of like this, just to show you guys that's like what those points would be. That's if there's 2 solutions. If there's 1 solution, that's not what we have here. You could have maybe a parabola and then the line just barely touches it right there, 1 solution. And then you could have 0 solutions. You have your parabola and then you have like a line that's never going to intersect it. Yeah. So anyways, that's what it would be like. 2 solutions, 1 solution, or no solution. Make sure you guys get your 3 questions on the left and a summary, and turn these into Google Classroom when you're done.